Good afternoon, all of you. So, I will start with the session and I'll try to explain each and everything. So, the important part is like how do we do a digital signature in PDF document or in Word document, and then also understanding the behind story, like what actually happens when you are digitally signing and how does it ensure that the digital trust is established. So that part also we'll try to cover. And then some of the concerns that people have raised, including Principal Secretary, that also I will try to address. So it's not like something is not already in place, you just have to implement, you just have to adopt. It's already there. Now to start with, so this is the agenda, and demo part I will take it after another session by my colleague. So let us start with attacks on physical document. Okay. So any physical document, there can be a content alteration. So after something has been signed, I can edit the content of the physical document, a paper basically. And then there can be identity related attack also. For example, I can forge a signature of someone else and it may be as good as the original signer. So that is another challenge. So for example, it may not be properly visible, but for example, this is a note. On the left hand side, you can see that the authority has written not approved. Okay, and he has signed it. After that, a person simply added a E. So not approved became not approved. It's totally possible. Okay. So this is so why this happened, because the signature was independent of the content of the document. Somebody signed and after that the content was altered, signature has not been touched, and we can see that now it becomes not approved. Now another example that I would like to show you is the signature on the checkbook. Now in this check you can see it's 6,000 and numerical also it is written 6000. I just have to add one more zero, and after 6 I will add a TY and it becomes 60,000. Totally valid, independent of the signature. Signature is separate, signature is valid, there is no doubt in that, but the document is altered, the document is corrupted, the integrity now doesn't match. So these are the attack on the physical document. Now what happens in the electronic world? Now in electronic world also we have attack on confidentiality. So ultimately when I am browsing any website, when I am surfing on the internet, my data from my mobile or from my computer, it goes to some other computer which is located in maybe in USA or maybe in India itself, in Mumbai. Okay. Now how does the data go? Through some router, through some switches, some cable. So anybody in between on that wire, they can do a tapping and they can see what is there, what data is going. For example, if you are a technical person, maybe you will know about Wireshark, using which I can see what is the content that is traveling on the network. Totally possible. So this is attack on the confidentiality, that somebody can see what data is flowing on the network. Now another attack is attack on the confidentiality. It's similar thing where I can see any important information like tender information, someone's business plan. So that is also there. Now the next attack is attack on integrity, where I try to alter the content. Okay, so some information is going, for example, transaction information is going, that deposit 1 lakh rupees in someone account. I altered and made that 99,999 to my account and only 1 rupee to that person's account. So I can alter the instruction that is flowing on the network because I can tap in the network. So this is called breach of integrity, where the content that is going on the network is altered. So it may be edited, it may be something may be added, it may be deleted also. That is also possible. And we also have attack on authenticity. So the challenge is that whom we are talking with, can we really identify that yes, I am talking to the right person? Now recently there are many phishing attack, that is called voice phishing, in which somebody calls and says that I am your uncle, I am stuck at this place, I was trying to send some money, and he will send you a SMS that he sent you 20,000 rupees by mistake, and you return 18,000 rupees. He only wanted to send 2,000 rupees. And instead of the bank SMS, he will send you SMS from his phone that he 20,000 rupees added in your account. Okay, so how do you authenticate that the person who is calling at the other end is the same person? Now, at least voice you can identify that no, he doesn't look like he is my uncle, or he is my mother or father or anyone. But in computer, it's just typing. It's just anybody can. I can copy paste Donald Trump's image and create an account his name. Okay. And now earlier it was like there that if you have an account, you can have a verified account. Now anybody can pay money on X and become a verified account. It doesn't matter. So in that way, how do I trust that the person that I am talking with, he is the real person whom I intend to talk to? So that is attack on authenticity, where a person impersonate as another and try to get the information, or try to ask you to do some activity. So with that, I come to basic elements of trust. So in the computer world, if I have to trust something, what should be there to make me trust an information? So the first part is privacy or confidentiality, where it says that only authorized person can view the information or read the information or any message or document. Not everybody can see this, only the authorized person. Okay. Now after that, the second part is authenticity, where we ensure that the message or any document obtained from the claimed sender. So if I received a email from Donald Trump, it's not like somebody impersonated and said that I am Donald Trump and do this, I will transfer you $1 million. Okay. So that should not happen. Next part is integrity, that whatever document I am receiving, whether it is the original document or did somebody change the content, did somebody added something, did somebody update something. So I also have to ensure that the integrity of the document is maintained. And finally, this part where he was also talking about Sri Gopinath, where he was saying that if I sign something, later I cannot deny that no, I did not sign. Okay, because in paper-based signature, maybe I can say that no, this is not my signature, somebody else forged it. But in computer world, how can I make sure that I cannot deny if I have signed? So basically, repudiation means to deny. So I repudiate that I signed. So repudiation is to deny, and non-repudiation is not being able to deny. So these are the 4 elements of trust, and in short we call them pain properties. P-A-I-N, pain properties. Now there are different techniques in computer to implement these technologies, and one of the technology is digital signature. Now before digital signature, let's move on to hand signature. So hand signature is a unique pattern, and it's a unique pattern. For example, I draw some curve, I apply particular pressure at some point, I make dots or whatever design I make. So that is personal to me. I know the trick how to make the curve and how to add any digit or letter. So that is my style, and that's a unique pattern. And how do I verify that signature is mine or not. So you have a, like bank has a sample signature, and then they see the signature on the checkbook, and then they match that whether they are same or not. So this is called visual comparison, that you have two signature and you are matching whether the given signature is matching to the specimen signature or not. Then is it reliable? No, forgery is possible. So for example, this is a handwritten signature. Now the question is, how does the digital signature look? So this is how a digital signature look, and we'll go back, we'll discuss about what is it. So what is a digital signature? So digital signature is a value. Just now you saw it's a number, a value that is derived from two things. One, the content of the a secret known only to the signer. So there is some secret which is known only to the signer. For example, in hand signature, it is my style of signing, how much pressure I am applying, how I am drawing the curve. So that is my secret. And the second part is the message being signed. So digital signature is not only dependent on the secret of the signer, it is also dependent on the content of the document. Okay. So now, if I sign and the content is changed, so my signature will not be valid. So whatever attack we saw in the physical world, where after signing somebody was changing the document, that is not possible here. So what does it ensure? So digital signature ensures three things. First is authenticity. So I am signing, my authenticity is established that yes, I am the right person to sign it. Now the second thing is integrity, that since it is dependent on the content, so it means that if I make any change to the content, the digital signature will be invalid. So it means that the integrity is maintained. Nobody can alter the content. And the third part is non-repudiation. Once I have signed, the required secret is only with me, because it requires a secret, and that is only with me. Nobody else can do that. So if I say that no, I did not sign, that will be false. So that's why it only puts three things: authenticity, integrity, and non-repudiation. It doesn't provide the privacy, because my document is still visible. You can see that. Only thing is I added an extra signature in that. So the signature will look like this. So digital signature ensures trust features. The secret cannot be shared, so it will be so non-repudiation, authenticity is established, and post-digital signing, document cannot be tampered, because if you tamper, then digital signature will become invalid. And with digital signature, we can also assure authenticity and non-repudiation, which we will see when we see the examples and demonstrations. Now the challenge is, how do we get the secret? Because we need a secret to digitally sign, and then later we will have more challenges. For example, I got a secret, but how do I tie a secret to me? Because secret will be just a number, and if you see a big number, how will you say that this number belongs to Mr. Anoop and this number belongs to Miss Lavanya, or this number belongs to Sri Gopinath? So for that also there is another technique. We'll go one by one. So first part, we'll start with basic cryptography. So cryptography is a method of achieving secure information and communication based on some mathematics. Earlier also sir was mentioning. And somehow it provides a mechanism to keep your information private, so that nobody else can see it. Only for intended user it will open. Now so this achieves privacy by converting your normal text into a ciphertext, which is not readable by a normal person. So the process of converting a plain text to a ciphertext is called encryption, and the ulta, the decryption part, is from the ciphertext to the plain text. So for example, I will convert a message to a cipher text and I will send to a person, and that person only can open and see what is the content. Now, if I in normal days, what I can do is I can write my message, put it in a box, put a lock, and send it to that person. The person must have another key so that he can unlock and read that. So that key is the one which will be we use to encrypt or decrypt. Okay. Now there are so for example, one example is this, where I am using a Caesar cipher and I am just shifting the characters by some number. For example, I am adding 5 to each numbers. So for example, H becomes M, E becomes J, and so on. So I'm just adding. For example, A is there. If I add 5, B, C, D, E, F, it will become A will become F. Similarly, B will become G, C will become H, and so on. Now, at the end, for example, if you go to add to X, if you add 5, then it will be circling around with A again. So X, Y, Z, A, B, C. So it will become C, and so on. Now if you see the number on the left, Hello Guwahati, you can easily see and understand, yes, this is Hello Guwahati. But if you see the number on the right, MJQQT, you will not understand what is it. Is that fine? Clear? So that's what the purpose of ciphertext is, that convert your text into something which not everybody can understand, and only that person can understand who has the key. For example, if you know that the key is 5, I added 5, you subtract 5 and you will get the original text. Okay, so that is the encryption and decryption part, to convert your text into something private, so that you only the intended person can see the final content. Now keys, there are 2 types of keys. So the first key is called symmetric key. Symmetric means a single key is there which is used for encrypting as well as decrypting, locking as well as unlocking. So for example, our house lock, the same key can be used to lock and same key can be used to unlock. So that is called symmetric key. And symmetric key encryption and decryption are very fast. So that's why it is used everywhere for encryption, decryption. Now the second is called asymmetric key, where there are 2 keys. One key is for encryption and another is for decryption. So for example, our car key, there is one key for locking and another key for unlocking. So that is example of a symmetric key. Now the good thing is about asymmetric key is that any one can be used for lock, another can be used for unlocking. But then there is a convention that I will use this part for locking and another part for unlocking. So that is called public key and private key, the naming convention. Now private key is only known to me, public key is known to everyone. So if you want to send me a message, how will you send? You can encrypt using my public key. Because if it is locked using my private key, only I can open. Because my private key is with me, not with everyone. Okay. So that is one way of sending information to someone, that you lock it using his public key, and now only he has the private key. No one else can open it. No one else can decrypt or unlock it. Okay. So that is the symmetric and asymmetric key. How does this look? So again, these are cryptographic. So they are all like numbers. Public key is a number, private key is a number. So this asymmetric key, this is also known as public key cryptography. Okay, and public key cryptography, you have 2 keys. One is public key and another is private key. And knowledge of one key doesn't give you knowledge of the another. It means that if you got one key, it doesn't mean that you can derive the another key. It is mathematically infeasible. So that's what I am trying to explain here, that from private key you cannot derive the public key, from public key you cannot derive the private key. So if you have any question, you can ask in between. That doesn't, that's fine for me. So these are another example, like I was telling that one key you can use to lock, another for unlock or decrypt or encrypt. So this will work because we are using different keys, but if I use the same key, then the final text will be broken. It means it will still be unreadable. Now I have to digitally sign a document. So what do I have? I have my private key. So I can use my private key to sign. And if you remember the digital signature definition, it was saying that it is something derived using my secret key and the content of the document. So content of the document is already there, only I have to have a private key of mine. So that private key I will use for digitally signing the document. And then to verify, everybody can use my public key because public key is known to everyone. So they can use that to verify. But the question is that what process do I use to sign and verify a document? So we'll go into that. So we'll start with the hash function. Now the hash function is important in the sense that it will be used to establish the integrity of the message, that whatever message I am sending, it is not altered. So hash function is a cryptographic mechanism that operates as a one-way function. So one-way function means from input you can get the output, but from the output you cannot get back the input. Now mathematically, if I say, for example, you may be using y equal to x plus 5. Now you can invert it, x equal to y minus 5. So it's operate in both way. But a hash function only operates in one way. You have got a input, you can get an output, but from the output you cannot get back to the input. And the output of a hash function, it is fixed. So for example, if I use MD5 one algorithm, so the output will be 128-bit size in computer, and that irrespective of how long my message is. I am at Cotton University or I write a history of being at Cotton University, the output of the hash function will be the same, 128-bit. It doesn't matter how long my message is. And second part is that if I make even a small change to the message, for example, I add a dot, I add a space, the message digest will be totally different. So suppose that I got one input I and a message digest, and I made a small change to the I. Can I able to derive the fingerprint? No, I cannot be able to derive because it will generate a totally different output. So these are some of the example, MD5 and SHA. SHA 1, 2, 3 are there. There are different algorithms. We'll see in the demo. So this is through animation, the example where this is a hash algorithm where I am generating from a given message, I am generating a hash, and the size of the output is fixed. Another example where I have just added a dot after PM, you can see that, and the message digest is totally different. You cannot have a relationship between the first one and the second one. And the important part was the hash is one way. It means that if I give it back the output, I cannot get back the input. So it means that we can use it for proving the integrity of the message. So how we will see. So these are some of the examples of hashing, and only thing is the size of the output will change. So like MD5 is 160, then 128, then SHA1 is 160 bit, and then SHA2 has different sizes. So only the size of the output changes, otherwise the properties remain the same. So now we'll move on to the signing part, that how do we do a digital signature. So for that, I have a message which I need to sign. I will apply the crypto hash to that, the hash algorithm, and it will give me a message digest. This message digest is also called digital fingerprint. So this is my step number 1, where I am creating a hash from my original message. And in the second step, I am encrypting this message digest with my private key. And whatever output is there, that is called the digital signature. So only 2 steps. First step is creating a hash and then signing that hash or encrypting that hash with my private key. In the third step, we just have to append the digital signature with my original document or original message. So in brief, so I have a sender, I have a message passes through the hash, it generates a message digest. That message digest is encrypted using the private key, which gives me the digital signature. I just have to append that digital signature with my original message and send it to the person who will receive it, the receiver. So 2 steps. I have message. I created a hash of that, the digest, and that digest I encrypted using my private key. Done. And the signature, of course, signature has to be sent to the receiver along with the original document. Now the second part is that a receiver received the document and the signature. Now how will I verify who signed it, how it was, so whether it was altered or not. So let's see. So we have the received message in which I have the content at the top and digital signature as the bottom. Now the first part I will do is I will put a hash on the upper message, the content, and then the signature was signed using my private key. I will try to decrypt it using the public key, because ulta I have to do. If it was signed using private, basically encrypted using the private, I have to decrypt using the public key. So I decrypted using the signer's public key, because signer only signed with the private key. And both will give me a message digest, because crypto hash also gives a message digest, and the decryption will also give the message digest, because message digest only was signed encrypted using the private key. I just have to compare that these 2 message digests, are they same or not. If they are same, it means my signature is valid. If they are not same, it means that somebody changed the content or somebody changed the signature, either of them. Or the third thing will be, maybe the key is not matching. So somebody signed with one private key, same public key, from the same set, the public key is not matching. So these are the 3 things. If anything out of these 3 happens, it means that my signature is invalid. Okay. So this is the verification step, where the receiver has message as well as the digital signature. On the message, he will apply the hash, and on the digital signature, he will try to decrypt using the signer's public key. Using both, he will get hashes. He just has to check whether the hashes are matching or not. If the hashes are not matching, it means that the signature is invalid. If it is matching, it means signature is valid. So these are some of the examples of digital signature. Now this digital signature look like just numbers. Now if there is a number, how do I verify that this number, this digital signature belongs to which person, whether it belongs to person X or Y? So that is the important part. So this is the recap. So digital signature is digital fingerprint of the message and signed by the signer's secret. So that becomes a digital signature. It establishes identity and authenticity of the signer, and then it also establishes the integrity of the document, because if somebody changes the document, the hash will not match, and nobody can generate a hash we already saw that from the output of the hash you cannot get the input, so you cannot see the original message. And non-repudiation to a certain extent. Why certain extent? Because for the full extent we have to know about the digital signature certificate. And this is the convention that for signing we use private key of the signer, and for verification we use public key of the signer. Now, so PKI ecosystem of trust. Now, if I talk about PKI, public infrastructure, so one part was the algorithm, which we already saw that there are hash function, there are encryption and decryption, which will generate the digital signature. But there are other parts also. For example, we have policy. So if somebody is doing a digital signature, there must be a policy, there must be law to support that. If there is no law, then there is no meaning of digitally signing something, because it will not be valid in the court of law. So there must be some policy, then there must be some standard. Standard means everybody has a same way of digitally signing. Otherwise, if somebody uses one algorithm to implement digital signature, how will somebody else verify that digital signature? So there should be some standard across all the signing and verification mechanism, so that it is interoperable and everybody can sign or verify without any change. And then finally we have implementation. So for example, if digital signature exists and there are no application, for example, if PDF doesn't support, Adobe Acrobat doesn't support digital signing, then what can we do? If Microsoft Word doesn't support signing, then what will we do? So we need some implementation, some application developers who come and implement those digital signature and PKI concepts in their application, so that we can easily do that. Now, I have a demo part, but before that I will ask ma'am to complete the presentation. So now the thing is that I have some number, private key and public key, but the question is, how do I know that this big private key belongs to me or another big private key belongs to someone else? So there is something called digital signature certificate, which binds that number with my identity. So ma'am will cover it, and after that I will be back with the demo part.
Sir, I have a question to you.
Yeah, please.
So main component of the digital signature is a private key. Suppose we have a text message and giving it the one-way instruction. It is sending a message like this, with a message like this. Just private key I am embedding. So instead of private key, I can use the message authentication key also, or my Aadhaar number also, because identity is the main issue. So if I am giving my Aadhaar number, I have the IDs as well as fingerprint. So if there is some technology by which we can verify whether that signer, that the Aadhaar number is matching with that IDs or the fingerprint, so will it work or not?
We'll talk about it. So there is already e-signing which uses Aadhaar. So we'll talk about that in during the demo and next part. So I had covered that we have a public key and private key, and that can be used to sign. And then madam covered that the public key is just a number. Then how do I associate that number with a person? So for that we have a certificate in which my information is there as well as my public key is there. So the certificate certifies that this public key belongs to Mr. Anoop, or this public key belong to Ms. Lavanya, and any operation done using that public key or private key will be attributed to that person. Now the question is, who can issue a certificate? So that also we saw that there are licensed certifying authority that can issue the certificate, and to monitor those license certifying authority, we have a controller. It is called the controller of certifying authority. And controller of certifying authority is basically established through legislation in India. So we trust them. But the question is, how does computer trust them? So for computer, every computer has a certificate manager, or it's like a trust store. And in that, the certificate of controller of certifying authority must also be put. Then only computer will understand. For human it is fine that yes, our authority is CCA, but computer also has to understand that the Indian authority is CCA. And in computer, the identity is in form of the certificate. So for example, normally we have our ID card. Now my ID card will be different from your ID card, the Cotton University or any other organization. But the standard for a certificate is fixed, that madam was talking. So we have a fixed standard X.509 in which the certificate will be stored and what all information it will contain. So from the user information to the certificate information to the signer, the public key, everything will be there. So we'll start with the demo part. So let us first start with whatever I. I will need internet connection. I'm just sharing it.
So you require internet connection.
Yeah, I'm sharing with my phone, but the speed is slow. The concept of public key, private key. So where is it? So it resides inside a crypto token, which looks similar to this USB. This is a USB crypto token in which my public key and private key are generated. And public key, it will be sent to the certifying authority to sign so that it becomes a certificate. Because only public key is of no meaning. So we have to associate the identity. So I will send my detail along with the public key in form of a certificate signing request, which will go to the CA, and then CA will generate a certificate for me. It will be signed by the certifying authority. And that certificate will be stored again back into this crypto token. And the good thing about this crypto token is that the private key cannot come out of this. And I can use it, and as Sri Gopinath sir was pointing out, that I can give it to someone. But the thing is, the responsibility lies with me. If I am giving it to someone, it is I am doing the breach. It's not that somebody is doing the breach for me. I am doing the breach. I should not have given it to someone. Okay. Second thing is, he was talking about the location. Well, you can capture location in this, but it is, as of now, it's manual. It's not tagged to anything geographical. And still, even if I am in the same office, I can give it to someone else. So in that way, the location will also not matter. Now, the part is, if I lose this crypto token, can someone use it to sign? Well, no, because this crypto token is also protected by a PIN or a password, which is a alphanumeric number, and only 10 attempts are allowed. So as soon as you put wrong password 10 times, it will be locked. And after that, nobody can use it, not even the original owner. If it comes back to me, I also cannot use it because I cannot unlock it. It will be locked. I have to revoke the certificate and get a new certificate. So this is one use case of revocation where somehow I locked my key. Now I cannot use it. That's why I need to revoke the certificate. And in fact, even if I cannot unlock it, whenever I lose it, somewhere I lost it, I must get it revoked. Okay, maybe someone was my friend and he looked over my shoulder and saw what password I was entering. So he may be aware of the password. So that's why it's better that if I lose this crypto token, I have to call the customer care of the certifying authority and ask them to revoke the certificate. Once a certificate is revoked, so whatever signature is done using that stands invalid. So there is no meaning of that once the certificate has been revoked. And already Madam has talked about, I don't want to go into that. So there is a certificate revocation list through which we can know which all certificates are already revoked. Otherwise, even if it is revoked, the verifying authority, how will it validate that whether it has been revoked or not? So there are two mechanisms. One is CRL, certificate revocation list, whose URL is also there in this crypto token. And second one is OCSP. OCSP is the online certification status protocol, which does in real time. So I asked it and it returned me the response that whether the certificate is valid or not. CRL is updated every 12 hours. It means that there may be some delay. For example, if I lost my token at 12 o'clock and the update happens every evening in the 4 o'clock, so till then I may be able to sign it because at that time the CRL is not updated. But in OCSP it will be in real time, so you can always validate using OCSP. So I think now all the operations are now moving on to OCSP. So this portal is only for learning. So this is learn.pkindia.in, and here we have just basically replicated the process of digital signature. So the first step is key pair generation. In actual, it happens in the crypto token, but this is just for demo, for learning purpose. So we can click here also on the generate and we can get a public key and private key. So as you can see, public key and private key are just some numbers written in base64 format. Then we can go to next and we can generate a certificate, because without certificate I cannot attribute a public key to a person. Okay, so that is the digital signature certificate process. You have to add your information, and based on your information the certificate will be generated. After that, I have to send a message, so I will compose it. Okay, and then I will go to next step, and the next step is about generating the fingerprint.
Sir, is the message the content of the this certificate? The document, content of the document.
Which I am signing, the document that I am signing.
Document. This is the message, is the content of the document which you are signing.
Yes. So I provided some content, just a random content, hello Cotton University, and then the first step in digital signature was to generate a fingerprint. The message digest using some hashing algorithm. So I can use, there are different hashing algorithms. Suppose I use SHA-256. You can see this is the length. If I use maybe 512, the length will increase, that's all. Okay, so as I said, the size changes. I will go back to 256, and if I change my message, suppose I remove this, I go back and click on generate message digest. You can see the length is same, only the content changed, and content changed drastically. It's not like I removed one exclamation and only A became B. No, not like that. So this is our hashing. Then we will go to the next step where I have already the message digest and I have the private key of the signer, and then it will generate a digital signature by encrypting the digest with the private key. So I will click on generate digital signature and it will generate a digital signature with just a number. We'll go to the next step, and this part is the verification part. So I have a signature, I have the public key, and I also have the message that I have received, and I want to verify whether all of these are in sync with or not. So if I click on verify, so one thing is it will generate the message digest from the text, as well as it will decrypt, and the decrypted will also become a message digest. So both it will verify whether both are equal or not. If both are equal means the verification is fine, okay. If I change a little bit in the message received, then in that case the hash will not match. So it means the signature is not valid. Is this fine? So this is just a demo for learning purpose. Now we'll go about how does it actually happen in documents. So we'll start with a Word document. So this is a Word document which I want to sign it. So I will go to File, I will go to Sign and Info. In the info you can see there is a Protect document. I will click on the Protect document, and then there is an option to add a digital signature. Okay, if I click on this, so it asks for commitment type. It's simple, I can put to none, or I can say I created and approved this document. Then purpose of signing, so maybe approved. And then who is signing? So can you see at the bottom, signing as Anoop Kumar Pandey and issued by Pro DigiSign Sub CA. So this is my crypto token. Now in my computer I can have multiple certificate. For example, I connect to my CDAC VPN. So for that also there is a certificate. So there may be multiple certificate belonging to Mr. Anoop. So the question is, which one should I use for signing? So I can use it, I can change, I can click on change, and you can see there that this is my UTM certificate. I can go for more choices, and you can see I have another UTM certificate, I have this Pro DigiSign. So you have to select with using which certificate you want to sign. So for example, I will select this. I will select this and click on OK. I don't have an internet connection. Don't have anything except proxy. Okay, so I will click on sign, and you can see it says connect a smart card. So which is my this crypto token. So I will connect it. And now it is asking for my PIN, because without PIN it will not sign. Now somebody will ask the question that this document, a private key cannot come out of that, so where does the signing happen? So basically the hash is created, and that hash goes into the crypto token. Private key cannot come out, but the hash can go inside, and there the signing will happen, and the signature will return back to the application. So I will enter my PIN, and then it says your signature has been saved with this document. If this document is changed, your signature will become invalid. So as I said that document integrity is maintained. It means that if any change is there in the document, it means my signature will become invalid. So I'll click on OK. And then I can go back, and you can see on the top also
this is digital signature demo. This is
so on the top it says that marked as final. The author has marked this document as final to discourage editing, because it has been signed, so nobody can edit it. But I can still try to edit, but only thing is it will invalidate the signature. The signature will not remain valid. So if I click on edit anyway, it will become invalid. Now where is my sign? So in the top it shows view signature. So I can click on the signature, and on the right hand pane you can see this is the signature, and I can extend and go on the signature detail. And now in the signature detail it will show that okay, this was signed for the purpose of approval, and who signed it. So Anoop Kumar Pandey signed it, and I can also view the information about Anoop Kumar Pandey. Okay. Now let us come to the certificate part. So this certificate, earlier madam was showing that this is the certificate. Now what does it contain? So this contains the subject information. Okay, so we'll go to second tab, and then go to, there are various other information. So we'll start with the subject. Now let me zoom it. Now can you see it says that Anoop Kumar Pandey, my email anoop@cdac.in is there. Then after that a serial number is there. This is the subject serial number, not the certificate serial number, and it is usually generated through hashing the PAN. And then my phone number is also hashed, and then after that my address is there. Can you see CDAC, Knowledge Park, Old Madras Road, postal code. In fact, my organization is also there, Center for Development of Advanced Computing. It means that I can associate this certificate with an organization. What sir was saying that how do I associate the person with the department and his designation. So that part can also be done here. It's just that you have to add entry in the certificate. After that, anybody can view the certificate and he can place me with that organization, that yes, Mr. Anoop belongs to this organization, and his email is also there. Is this fine? Okay, so this was the, and then after that the now another part is that technology is changing. Every now and then something comes and we have to change the algorithm, we have to change the key size. So therefore the certificates are not valid forever. So it comes with some validity, 1 year, 2 year, 3 year. Now crypto token I can reuse in the same crypto token as long as it supports that algorithm. For example, I am using RSA, tomorrow the algorithm changes, maybe I cannot use the crypto token, I will have to buy a new crypto token. But otherwise, if only key size changes or key size remain the same, I can use the same crypto token, because crypto token is also costly, 600, 700 rupees. Certificate has a separate pricing. So I can use the same crypto token to get a new certificate from the certifying authority after the expiry of 1 year or 2 year. Okay, so this is the validity part. I have taken with 3 year validity. And then this is the issuer. Issuer means the certifying authority which has issued the certificate. So that information is also there. You can see it is a ProDigi site and their office address, everything is given. Okay. Now after that we have the CRL, which I was talking about, that if your certificate is revoked, either you lost your key or you lost your crypto token, or you need to change, maybe somebody you mistrust that person may be knowing something, or you entered too many times wrong password and your key is locked. So in all those cases, or maybe CA discovered that you entered some wrong information while obtaining the certificate, or maybe you changed the organization. So I moved from CDAC to ministry, and then but this certificate is associated with my CDAC account, so I need to revoke it. So in all those cases, my certificate has to revoke and it has to put in the certificate revocation list. So this is the URL of the certificate revocation list. I can copy it. I will just try to, I will show you this list.
So in how many devices you can use this?
In how many?
Devices we can use the crypto token.
In any device you can use it.
In that case, the PIN may be different.
No, PIN is associated with the crypto token. It's not associated with the device. PIN is for the crypto token. So this is my URL of the CRL. I can go to browser and just put it, and it will download a file. I will open this file. So I opened this file. You can see here this is a CRL and revocation list, and in the revocation list it's not responding. It will just open. Just 1 minute.
Who maintains this revocation list?
So the revocation list is maintained by the CA. They issued the certificate, so they will maintain the.
How is it going to go upper in the
No,
hierarchy?
each CA will maintain their own CRL. So if I got my certificate issued from eMudra, so if my certificate is revoked, it will be present in the eMudra ka CRL. Fine. Then your CSA will also have a revocation list. For example, it licensed a CA and in between their license was revoked or maybe suspended or cancelled. In that case, their certificate will be pushed in the CRL of CCA because their certificate was issued by CCA. So all the CAs, they maintain their separate list and update it every 12 hours. And but the OCSP service, that is the real-time thing. And nowadays they have moved to OCSP. So here you can see in the revocation list, these are the list of certificate that has been revoked, when it was revoked, and usually there will be a region also. So these are the list of certificates which were revoked. So you can use this CRL for verifying the signature done by any certificate, because you have to ultimately see that at the time of signature. Now remember, this is important, that maybe I signed a document and after that my certificate was revoked. So at the time of signing, if the certificate is valid, means it is not revoked or not expired, in that case the document that I signed, that will be valid. Okay, so we only see at the time of signing what was it. Now next we'll see the demo on the Adobe Acrobat. So in the Adobe Acrobat, on the left hand side, we can go to view more in the tools. All tools are there. Left hand side, view more, and there is an option to use a certificate. Use a certificate. I will click on that, use a certificate. If it is not visible, I will just zoom it. So use a certificate is there. I will click on that, and at the top it will show digitally signed. Okay. Now when I signed in the Word document, the signature was not part of the document. It was on the separate pane. You saw that, no? But when I sign on the PDF, I can put it on the document itself. Now remember that this signature that I am putting on the document, it is only for appearance, how it looks. That is not the actual signature, because as I said, digital signature is a number which is hiding behind. But how it will look on the document, that is the appearance part. So for appearance part, I can just create a box where my signature will appear. First I will have to click on the digitally signed, and then I will have to create a box, that in this box my signature will appear. Now again here I have multiple certificate, so I have to select which certificate do I need to sign it with. Okay, I will unzoom it. So I will select my certificate and click on continue. And after that, again the appearance can be configured. Like what do I want in my signature? For example, I will click on edit. Do I need my name? Can I have the logo? Can I have my distinguished name? The location? The labels? So everything is configurable. What I want in the appearance, that part is configurable. Now if you see, my name is written in Hindi, my signature is in Hindi, that also I can change. I can click on browse and I can select some other image. That is fine, because this is appearance. This is not the actual signature. This is just the appearance.
Question: why do we put so much of effort in the appearance? Because appearance doesn't say about the signature. Actual signature is the number. So if someone wants to validate through the appearance, no one can validate it. Why put so much of effort?
True.
One can just crop it and then paste it in another box.
True, but we are still in transition mode. So, for example, today still people say that we have to sign on all the document, all the pages of the document. Though signing on one page, that is sufficient. But in Office there is a format in which you have to sign at the bottom of that, so that it looks like your name should appear. For example, when you used to sign, it will say that put it your name, date and the sign. All these three things should be there. Okay, otherwise at least so appearance is just for maybe aesthetic purpose or maybe for understanding purpose, that this document has been signed by Anoop. But the verification will happen after you click on that signature, and then only you will know that who actually signed it. Okay, so you can change the appearance, and finally you can save it using some preset, or otherwise I will simply cancel it because I don't want to use any appearance as of now. I will simply click on OK. I can add any region also. I can add any reason. For example, I approved this document or I rejected. You saw that, no? Note approved and not approved. So that part I can put it here in the reason part. I can also add location. Though this location is like manually fed, it's not taking from GPS or anything, so I can put any location. I can also add some contact information, but all those are all in appearance, because I can edit it. Instead of writing Guwahati, I can write I am in US. That's fine. Then I will click on the sign part. One minute. It's not detecting. I will just restart it. View more, use a certificate, digitally signed, create a rectangle where you want your signature to appear, continue. I think it requires internet, let me. This internet is not working.
Will this provide integrity of the document? I can edit also. Is it for appearance or for integrity?
No, it's for integrity. I will show you. Yes, because yours is not. So it will ask me to save the file. Once I click on the sign part, it will ask me to save the file separately. I can write on the same file, or I can save it with a different name. So suppose I am saving with version 1, click on save, and it will ask me for my PIN, because without PIN the device cannot access my private key. So I will enter my PIN, and then my signature is done. Okay, now the verification part. Signature is done. Now the verification part, first thing you can see on the top, signed and all signature are valid here. Signed and all signature are valid. It means my document has already done the verification, including the CRL part, including the expiry, the certificate chain, whether it has come from Root Certifying Authority of India or not. So all those steps have already been verified, and then it says that the signature are valid. Second thing is, I can always click on this signature. Can you see hand icon is appearing? I just have to click on it, and then it says that signature is valid, signed by Anoop Kumar Pandey, Anoop@CDAC.in. So it is associating my identity with this signature, that Mr. Anoop has signed it. Further, it also says that the document has not been modified since the signature was applied. Now whatever in the morning they were saying that, can I lock the document after signing? Yes, you can lock. Did you notice the option of locking the document?
Yes.
Yes. So there was a tick mark. Let me try again.
Lock the document after sign option was there.
So can you see here, lock document after signing? It means that after I signed, so nobody else can tamper it. In fact, but often in the office we require that I signed, after that my superior will sign, maybe after that final authority will sign. That's why we do not mark final. Now, if there are 3 signatures on the document, then which content was used for signing which document, because ultimately the signature is dependent on the content. So it happens like that when I signed on the content of the document, the first one. After that, when my executive director signed, it contains the content of the document plus my signature as input. Both are input for his signature and so on. So this will go recursively. It's like putting something into the packet, somebody signed, after that again putting the entire thing inside another packet and somebody else signed. Is it fine? So I can lock the document, after that it will not be editable. So I will cancel it. Now next part was, which I was talking about, was appearance. Appearance can be misleading. I can put anything. But appearance is also for people to see, like who signed it. But as a technical person, I always have to click and see who signed it. For example, if you see this signature, this is R. Balaji signature. Right? Looks like R. Balaji, but if I click on it, then you will know that signature is valid and it is signed by Anoop Kumar Pandey. Because in appearance, I used his hand signature. I can copy paste. It's a computer world. I can copy paste his signature from anywhere he would have signed. So as a person, as a technology person, we must click and see the certificate. So for example, if I click on the signature properties, then it will show further information. Signature is valid, signed by Anoop Kumar Pandey, signing time also it shows. And then the document has not been modified since the signature was applied. The document is signed by the current user, but means it is also detecting that my crypto token is there and it was signed in the same system. And then I can click on show signer certificate. So maybe on the top it is only showing Anoop and Anoop at CDAC.in. Let me see more information about them. Then I can go to signer certificate and again it will be back to the same hierarchical information about Anoop, then the CA that signed it, then the root certifying authority, same as the thing that we saw in the Word document. Okay, so this is the hierarchy, and then if you go in the detail, it will also show the detail of the signing, same things, the subject, the issuer, the serial number, validity, start, and CRL distribution point, and other thing like public key. So all the information same as what we saw already in the Word document when I was signing, because certificate remains the same whether I am using on any platform or any application. Okay. Any question?
So once the certificate is in revocation list, so will the system allow someone to sign the report?
No.
So you see we have to validate.
So whenever you open a document and you try to sign, first it connects to OCSP service, and then it sees that whether the certificate is still valid or not. If it is not valid, then the application will not allow to sign it. Now it is so that's why I was saying that if for PKI system to succeed, we need everything: policy, law, we need the algorithms, RSA, we need also the applications which are supporting this type of thing. Otherwise, you can develop any any application that will allow to sign even without validating anything. You are the implementer. Okay, but once it goes to any other system, I open that system in my Acrobat and it will tell that the signature is not valid even though you generated it maliciously. Okay, so any more question? Otherwise, we'll conclude for my session at least.
Thank you very much for this detailed deliberation. It really helped us. I just have one observation. Earlier today, Gopinath sir said that there are two challenges which he would like the researchers to address. One was that his designation doesn't come under his name. But here we see that the designation does come under the name. Again he said, what was the other point? That was also shown here, that it is done.
The
Huh?
person can give it to someone else, so
Yeah.
how do I attach a
Yeah,
person?
yeah. So that was also done. But why didn't you tell him then that these have already been addressed?
No, I think
It's
ma'am,
not
there is
left
one-
for the
there is
researchers.
One thing probably, the way it is implemented by Assam government,
Huh.
the system that Assam government has adopted, probably that system implements it like that way,
Yeah.
that the designation is not attached with the
Yeah.
person.
But
I
that
think,
thing has already
yeah, that
been done
flexibility
and
can
can be
added.
implemented, I
Ma'am,
suppose, here.
there are
Because
two things. One is between the different work between the technologists and the bureaucrats, and second one is professional secret. So I think
is what I understood from what he said is that these two things are still left open for the researchers because it is not done. The designation should come and whether the person is that means, but both the things I see have been already been addressed by CDAC
So
and
what he
shown
said
here.
is from basically from bureaucrat
So
point
it
of view.
can be used here, I suppose, in Assam.
The dongle can be given to someone and he can sign on his behalf. The server say whether I can ascertain the presence of the person who is actually signing.
Yeah, that is okay. That challenge is
That
there.
challenge is still there.
That challenge
can
is there,
be-
but the other one is
our
solved.
dongles don't carry the designation basically. Mainly maybe
No,
sir
that challenge will
handles-
be if in near future we may go with this dongle may be verified other than pin, it may verify with the fingerprint or the iris. That's an additional. Like in banks, it's with the fingerprint. That may be additional.
but-
No, that is okay.
But
That is okay.
in our government,
The presence part is also okay, we cannot verify, but the other part, since it's already there, why doesn't Assam government also
maybe
implement
it's
that?
because one person sometimes holds multiple portfolios.
Yeah, and it keeps on
So
changing also.
right now, Gopinath sir has one portfolio being the principal secretary of IT.
Huh.
But it so appears that there are officers who will be holding multiple
Yes, I see.
departments. They will be there. Again, he may be chairman of some other committee. He may have to
Yeah.
sign from that.
Yeah.
So that's why maybe the designation is not
That is
given.
why it is
That is
left
why.
out,
So
yeah.
so that you can otherwise you'll be carrying multiple dongles.
Many dongles.
Many
right.
dongles.
Yeah.
And it might create a confusion. That's why.
But thing is that is why probably Assam government is not giving that.
Yeah.
But it is
Ours,
not a
our
challenge
dongle
for
is
the
basically,
researchers. It's already done. It's
yeah,
already
we
done.
use that only in the context of e-office.
Yeah.
It cannot be utilized outside. Or for signing some other document.
Yeah.
Okay,
But
so
we
By
can
the
do
way, he is Mr. Sahabuddin Ahmed. He
Coming,
was our
coming.
student from the physics department and he is working as the under secretary in Sir's office only. So that's why he is giving the explanation.
So the digital signature satisfies the pin property.
not the P part. Privacy is not there. Because for privacy you need to encrypt. That is called sign encryption. Signature plus encryption.
So,
That is there.
so suppose the this private key, public key, the generation is compromised. The key generation property is compromised due to some recent technology like post-quantum cryptography. So in that case, whether the digital signature concept will be continued or it will be obsolete.
It will be continued. So whenever technology changes, so we also adopt those technology. For example, CDAC is already working on a crypto token which supports post-quantum cryptography. In fact, our CA software is already ready. Post-quantum CA software is ready, which will issue the key both. So currently we are using the hybrid approach, in which RSA key is also there and dilithium key is also there. Dilithium is used for the digital signature in post-quantum. So both key will be there, and depending on what system somebody is using, they can use either post-quantum or the RSA key. So it's possible in the same certificate it will be there.
Certificate will not be.
Certificate will remain the same. So certificate is a standard. What information we put in that, it is up to me. For example, my office has added all the required information related to me in that my certificate. Second thing is one more thing, that if a person has different roles So he can have multiple certificate, and in a single crypto token I can store multiple certificate. It's not like I need another crypto token. In a single crypto token you can have multiple certificate. That's fine. Only thing is all the certificate will be protected by the same pin. That's fine. As long as all are with me, all the certificate, it's fine.
Even if it's from a different organization, will that also be possible?
Yes.
Only to carry the token.
Yes. Crypto token is mine. Where do I generate my key pair? It is up to me. Because when the CA issues a certificate, they send me a software. That software generates the key pair. And I tell that software that this is my crypto token, you generate in this. For example, in your computer, there are so many drives, C drive, D drive, E drive. It is up to you where do you store, in C drive or D drive. So same way I can have a single crypto token where I can store multiple certificates. And it is totally legal to have multiple certificates at the same time, in the same name.
So one query, how much expenditure coming for this certificate generation from one officer, tentative? Because again it comes to cost.
No, the costing is like if you buy as an individual, for example, from eMudra, if you buy a certificate, around it will charge you 5,000, 6,000 rupees with crypto token plus 3-year certificate and the encryption certificate also. But like we go through GEM tendering process, we get 600, 700 rupees per person. And in fact, it can reduce further. Because all the cost is for the crypto token and hardware cost. Software cost is one time. Once the key pair generate, you got the certificate. It's not like I have to continuously probe to the CA. And they just have to maintain a OCSP so that validity can be verified, whether the certificate is revoked or not. Now another thing was e-signature part. So many people say that this crypto token is maybe costly and I barely use it. Now for us it is like daily. I have to sign 10 documents on a daily basis. Some approval I have to give, some request I have to generate. So and in our office everything is, there is no paper document at all. We are only generating digital document which is stored in our cloud and we sign one by one. And as sir was saying, Gopinath sir, that e-office is there. So that's where also you sign only. So the question is, if a person who doesn't have that much use and if it takes like 1,000 rupees also for a year, it's not viable also. So what we can do is we can adopt e-signature. And in fact, that was also discussed that when we submit our tax return, when we file our tax return, we sign it using our Aadhaar OTP. And in that case, a temporary certificate, key pair is generated and a temporary certificate is assigned using which your tax return is signed and submitted to the office. Apart from that, CDAC has a separate e-sign service, esign.cdac.in, and many service provider, they redirect you to that service. For example, recently I bought some property, and for that they sent me the document online and they asked me to e-sign the document as an acceptance of that offer. And I e-signed it using the Aadhaar, CDAC's Aadhaar e-sign facility, where I have to add my Aadhaar number or your virtual ID is also fine, and then OTP will be generated and the document will be signed. So those certificates are only valid for 30 minutes.
Okay.
After that it will expire. But my crypto token is valid for like 2 years, 3 years, which I can reuse it. But for Aadhaar based e-signing, it is only for one time use and it will be only valid for 30 minutes, that's all. And for example, when I use my crypto token, so private key is in my control. But when I e-sign, the private key is in with the organization who is providing me this facility. For example, CDAC has HSM. HSM is like big brother of this crypto token. So instead of a single crypto token, they have a big crypto token where all the key pairs are generated inside it. Okay, and using that we sign. So e-sign provider have a that kind of HSM, and that HSM are used for generating the key pair, and using that key we sign. But that is only valid for the certificate is only valid for 30 minutes. But anyway, it's for one-time purpose. That's fine, and its cost is very less. Any other question? Sir? Okay, thank you.